Thanks for clicking. I'm Tate Shafoli. Welcome to my channel, and in today's lesson we'll be looking at this rule of indices. A to power m multiplied by a to power n is equal to, or it's the same as, a to power m plus n. This rule was discovered by a mathematician long time ago, before we were born. And this rule says that if you find numbers multiplying each other in this form and the bases are the same and there's a multiplication sign, we must only write one base and then we add these indices together. You can see how I have written a to power m plus n. These bases must be the same and there must be a multiplication sign. 2 to power 4 multiplied by 2 cubed can be simplified, or it's the same as 2. You can see how I have written 2 only because we have two bases which are 2, 2, and there's a multiplication sign. So therefore I have just to write one base and then add the indices together. 4 plus 3, and it's going to be 2 to power 7. This 2 to power 7 is the same as 2 to power 4 times 2 cubed. The only difference is that this one is longer and this one is shorter. 3 to power 4 times 3 to power 5 can be written, or it's the same as 3 to power 4 plus 5, which is equal to 3 to power 9. This 9 is the result of adding the indices together. 4 plus 5, you can see I've added my indices. 4 plus 5 is equal to 9. 4 to power 7 multiplied by 4 cubed can be simplified as 4, 7 plus 3, and then it's going to be 4 to power 10. This 4 to power 10 is the same as 4 to power 7 times 4 cubed. 7 squared times 7 cubed can be written as 7 to power 2 plus 3, which is equal to 7 to power 5. Now let us prove these numbers on a calculator, because we cannot just believe it, but we must prove it. Alright, it's now time for us to prove whether this mathematician was correct or wrong. Let's prove this one on a calculator. 2 cubed multiplied by 2 to power 4, the answer is 128. But how about if we write only one base, which is 2, and add the indices together? What is 3 plus 4? And then punch in only 2 to power 7. 2 to power 7. Let's look at the answer. The answer is the same, which is 128. Wow, this mathematician was very clever. Okay, let's prove other numbers. 3 to power 4 multiplied by 3 to power 5. The answer is 19,683. How about if we punch in only 3 and then we add the indices together, which is 4 plus 5, and then we punch in 3 to power 9. Let's have a look at that. 3 to power 9. The answer is the same, 19,683. Wow, this mathematician was very clever. How about 4 to power 7 multiplied by 4 cubed? The answer is 1,048,576. How about if we just punch in 4 to power 10 after adding 7 plus 3? Let's have a look at that. 4 to power 10. The answer is, wow, it's the same, 1,048,576. What about 7 squared multiplied by 7 cubed? The answer is 16,807. What about if we punch in only 7 and then we add the indices together? 2 plus 3, which is 5, and then 7 to power 5. The answer is, wow, 16,807. The answer is the same. You can see that this mathematician was very, very clever. This rule, a to power m multiplied by a to power n, which is equal to a to power m plus n. These are the letters that the person who discovered this rule thought of during that time he was communicating to the world. Now your task is the teacher. Ask your learners, assuming, or let's say they are the one who had discovered this rule, they would have not used these variables a, m, and n because we think differently. Now their task is to come up with this rule, but now using different variables. Some learners can use b to power r times b to power k is equal to b to power r plus k, while some will write t to power y multiplied by t to power p can be simplified as t to power y plus p, and so on. And your task is just to mark. You give them ticks. Like that, you are teaching. Thank you for watching, and please do not forget to subscribe and turn on your notification bell so that when a video has been uploaded, you'll be the first one to view it.